In this demo, we'd like to create our own AOP framework from scratch. Basically, we won't do it from scratch because we will use a library to manipulate the Java bytecode, but nevertheless, the idea is to understand how the AOP framework is working and what we can do in order to implement such framework. Let's start by creating a new Java project. In this case, let's just call our project AOP. That's going to be a simple AOP framework. And while we are adjusting a bit the, the outline, let's just then create in our source folder a package called why not AOP. And basically we'd like to have a test for that, so we're gonna create a simple service. Let's just add a new source folder and call this test, and in here create a new class that's gonna be our service, and let's just say that we will have a simple method which will be like a hello world. Let's call the method say hello, and this will return some string. So let's then just return a simple hello, and let's just add the name. Okay, so what we'd like to show is the ability to intercept a method from within our service, and for that we'll just do a simple call of our service. Let's just then create a new class that's going to be our program, and this will contain a main, and in here we will just create a new service. Okay, and of course we will call this in order to show the result, so we'll output the result of calling service dot say hello, and let's just pick my name for that. And the idea is that we'd like to implement a way that we can intercept the call to the service. So in our framework or pseudo framework, we'll have such an interface. Let's call it point cut. Actually, this is going to be an aspect with only one point cut. So the idea is that we'd like to be able to intercept the execution of a method. Therefore, we should have a filter method which will tell whether or not this should apply to a method, and we need to know what is the name of the method and from which class the method is. Next, we'd like to define some advices around this point cut, such as before executing the method and after executing it. So let's just implement by default those, and we have a before advice, and this will receive as arguments, for instance, the name of the type, then the name of the method. Additionally, we'll have the target which executes the method, like the instance calling the method, and a bunch of arguments. So this is going to be our arguments. We will implement this method by default by doing nothing, just for the extenders, the implementers of this interface, not to have to say to implement those methods, but rather choose which one they want to implement. So we'll have an after advice. The after advice will receive the name of the class, the name of the method that's going to be executed. Additionally, this will receive the target that's executing the method, also the result of calling the method, and then some arguments with which the method was called. All those might throws exceptions, therefore we will say that this is throwing throwable, just for the sake of not catching any exception. Okay, so having defined those advices, Let's just then see how we can implement an AOP framework. Basically, the idea would be to wave a class, to wave all the classes at runtime by implementing an agent. A Java agent, it's a component that's going to be called before actually running the main of our program. Therefore, our agent will have to register a class transformer which will handle the loading of the classes, and then we'll be able to intercept and inject the calls to those advices based on the point cuts that can apply to a class. So let's just go in here and create a new class. Let's just call the class aspect agent, and the aspect agent, it's a simple class that must have a public static void method called pre-main. This will receive a string which is the arguments of the method, and will receive an instrumentation which is the support to register additional stuff when calling the method. And what we would like to do would be to register a new transformer that's gonna be a new class transformer, and let's create our own class for that. Let's call it aspect file class file transformer. Come on, let's spell it correctly. Transformer. Not again. Yeah. Sorry. Transformer. Okay. So let's just then create this class, and it has to implement an interface from Java Lang instrument, which is called class file transformer. So the purpose of this agent is just to inject the class transformer. That's going to be the one that does the injection and attach the interceptors. Okay, so the class transformer itself, it's not so complex. So this will receive a class loader, will receive the name of the class. Let's just call this type. We'll receive the class, eventually the class being redefined, but we are not gonna use this, and we'll receive the bytecode of the class. And what it has to do would be to use an aspect manager and see what aspects need to be attached. In order to manipulate the class by loading the bytecode that was received by this transform method, we need to use a class pool. All those objects that we are about to use are implemented by a Java bytecode manipulation library, which in our case we will use Java Assist by JBoss. So I just loaded here their site on GitHub, and I'd like just to download the support. When we open this, we see inside that we have a jar, and we will just add this jar to our project. So let's just then create a new folder in here called lib, and we'll just do a copy and paste of this to our lib folder. Then we add this to our build path in order to run our bytecode injection. So what we do, we take the class pool, and the class pool is actually a singleton, so we get the default class pool, and what we try to do would be to create to load the class and modify its bytecode. So this is going to be the type name. Actually I will just call this type name, because here I would like to define a type. And with Java Assist, they provide a metadata similar to reflection to reflect the type definition. So what we try to do here would be, would be to start loading the type. In case we are catching an exception, we will, this method is throwing an illegal class format exception, so we will have to throw a new illegal format exception, and we'll provide as information the message from the inner exception, and eventually what we'd like to do would be to return the bytecode that we receive, but we need to make sure that if we manage to load the type and attach to the type, then in the end we detach to the type, so we call the detach method in the finalist block. Now what we do here would be to load the type from the bytecode, therefore we are using the bytecode to create a new stream, a byte array input stream based on the bytecode. So what we do, we take the bytecode, create a stream to read from it, and use the class pool to load the bytecode. We need to load the bytecode in order to reflect the definitions inside and see what are the methods of the type, and then call the aspect manager to see what aspects and what point cuts we need to attach to that. So what we do in this case would be to take each method from the declared type, the declared methods of the type. So we take the declared methods. We could take also the declared behaviors, which includes methods and constructors. So we then iterate with this. It's similar to reflection model, but it's not reflection, it's the support from Java Assist. And we check if the method it's not empty. We wanna make sure that we attach to a valid method, and then we try to change the method, and we create this method to change this method. So eventually this is what we do. The change method will inject the dependencies, and we have to make sure that in the end the bytecode is returned for the type, which means that by changing the bytecode, the original bytecode, we modify the class definition and we inject the point cuts. So we will create an aspect manager for that, and we'll consume the aspect manager in a singleton manner. The aspect manager will then collect all the elements and will be able to tell us if the method should be intercepted or not. So let's then have an aspect manager. The class doesn't exist, so we will create it, and we'd like to get the instance of the aspect manager and try and see if this method must be intercepted. We need to provide the name of the type, so we take the declaring class, and we also need to provide the name of the method, so we just get the name of the method. The aspect manager does not exist, so we then create the class aspect manager for that. There is no getter for the instance, the singleton instance, so we now create this, and it should return an aspect manager. Okay, and in the end there is no apply method, so we then create the apply method for that. So this is the approach. Of course we're gonna actually implement the class, but now let's take it top to bottom and use this in our code. So if we scan the aspects and find point cuts that should be attached to the call of the method from this type, then we need to modify the call of the method. In order to do so, Java Assist provides us with the ability to insert before. So we may insert some code before the execution of the method, and then because this might throw an exception, we have to throw this outside. Then we need to insert after also a call. What we'd like to actually call would be, we would like not to inject too many calls in the code of the method. but rather we will do the following. We'll take the aspect, so we'll have, when we try to see if there are point cuts to be applied to this method call, we'll then collect the point cuts. And in the end, we will call a static method of the aspect class, which will execute the before advices. And in order to call the execute of the before advices, we need to pass what was the target of the method, and JavaScript, I was talking about Assist. Java Assist library provides with a syntax that $0 is the target which executes the method we want to inject. $args are the arguments as an array. We can access them by the index, so $1 will be the first argument of the method and so on. But in this case, we just call a method of the class of the aspect manager to execute the before advices. Then we call the execute after advices, but in this case we have to provide not just the target and the arguments, but also the return value of the method, and $_ is holding this value. Okay, so basically what we have here, it's a simple interception in which we execute via a singleton instance of the aspect manager. We dispatch the call to all the before advices collected previously by the apply method. Okay, so in this manner we only have to deal with a simple injection of before and after interceptors. Now let's then focus on our aspect manager. So here we need to have an aspect manager instance. There's going to be a singleton. We will define a private static final flag, which could be an object that we then instantiate in here. Should be a new object. Okay, so what we'd like to do first, we'll have a private constructor for private count. Should be a private aspect manager constructor. Okay, and in the getter we will check if the instance is null, and if so we'll try to synchronize the access on the flag, and once again with a double check lock, if the instance is still null, then we make sure that we instantiate our singleton. Come on. So we then create a new aspect manager, and in the end we return the instance. Okay, now the second step we need to take when we load the aspect, when we create an aspect manager, we need to configure what aspects to load. So let's then try and implement our testing aspect. So let's just create a new class. Let's call the class myAspect, and with this class we should implement the, it's not actually, let's call it myPointCut. It's an aspect with only one point cut, but let's just call it like so. So the idea is that we'd like to intercept the call of any method in the class called service. So we check that the name of the type is equal to the one defined there. So for any method of the type, we say that we should apply this. But then we override the before advice and also the after advice, and instead of calling the default implementation, we will just output something in the console, like for instance we are in the before of an aspect, and we add the type, and then we add the name of the method. Okay, we'll do the same with the after advice, but in this case we just output that we are on the after call. And of course we'd like to do a debugging and see that what were the arguments and what was the target. We don't output those. Normally we define those aspects with point cards so that we can enhance automatically with some services, with additional services, the implementation of the class. But in this case we are just showing that we were able to intercept the calls of the methods of the service. Okay, so eventually we'll need to define a way that we specify which aspects to be applied. So let's then just create a new source folder called resources, and in here we should have a properties file like called AOP.properties, and these properties, come on, let's just call it AOP.properties, and this should hold the name of the aspects containing the point cards. So in my case it's AOP.myPointCard, the one which I like to attach. So what we'd like to do would be to use this file, and if you try and see what is the what's in the binary part of our application, we see that the file was copied here. So we'd like in the aspect manager to have like a property, like a private static final string for the name of the key, and this should be the property that's holding the point, that's pointing to the point cards file. So let's just call this point cards file, and for a simple name it should use AOP. And in the aspect manager, in the constructor, we should read this file. So basically what we do, we'll need to store all the point cards in our class. So we need to create a private list of point cards, and we should have objects of type point cards, and let's just say that this is going to be our point cards. So let's create an array list of point cards, and then we'll need, when we try to apply the point card, this will be the type on which we try to apply, and this will be the name of the method that we try to see if some point cards are applicable to that. So eventually we'll need to store a cache when we try to filter, to know for each method what should be the list of point cards that need to be applied. So in my case I will just concatenate the name of the type with the name of the method, and I will have a list of point cards that applies to this. So let's just call this method point cards. In here I will instantiate the method point cards as being a hash map, and then I need to read the file and load the point cards. Therefore, in order to load the point card class, I won't use the class loader because this should be happening before loading all the classes. Instead I will use the class pool. So the class pool, as you saw, it's a singleton, so I just take the class pool and call the get default. So what I'm doing here is actually trying to get the path to the point cards file. So this should be the point cards file, and I will take the system property which is called point cards file. I'm not checking if the point cards file exists or not. I will just read it. So I will read all the lines in the point cards file. So let's just read all the lines by calling the files from NIO support read all lines, and I will get the path that I received as argument, as the string argument, which is pointing the file. And now I'll just read each line from the lines. I take each line from the lines, and I'm trying to load the file. But of course, if I have empty lines, then it makes no sense to try to load the class out of them. Otherwise, we are loading a type, and with the pool we try to get a class by its name. So we take the line and we load it. This is not returning a class, but we can convert it to a class and it will return a class eventually. This might throw exceptions, so we have to deal with that. But nevertheless, after loading the type, we need to instantiate and create a point cut. So now I'm creating a new point cut by calling the default parameterless constructor of the type. This can throw a bunch of exceptions as well. But first we need to cast this to a point cut. And in the end, of course, I will just add the new point cut to the list of point cuts. Okay, so I'm calling the add method point cut dot add, and I will just pass the newly created point cut. Okay, so when we load the file, we then read each line from this configuration file, and we are actually loading the aspects from that file. This can throw a bunch of exceptions that we need to throw them outside, and in the end we have to make sure that all those exceptions are collected in the throws declaration of each method that we have. So eventually we have to change this a bit, but nevertheless it's not a big deal. So we just say what exceptions we can have, and in the end with this we are able to actually implement our filtering and not just filtering. So when we apply the point cut, when we try to see if for a method we have point cuts, we then need to collect those. So let's just create a list of point cuts again. Let's just call this point cuts and create a new array list for that. Okay, and let's iterate over all the point cuts in our already loaded point cuts and check if this apply. So we check if the point cut apply to the type and method, and if so, we then add this to the list of point cuts which apply to this method. In the end, this might throw exceptions. Let me just check. No, it's just that. Okay, so in the end, we have to check if we found some point cuts that apply to this method. So we check the size of the array, and if the size of the array is greater than 0, then we need to cache that. So let's say that the key for the method for which we store those would be composed out of the type and with the separator and the name of the method itself, and we then put this in our cache so we can use them later on. And of course in this case we should return true, and otherwise we should return false. Let's just keep this structured. Okay, so now we know when a point cut should be applied on a method. In order to execute the before point cuts, we need to have a method which will return void, and let's just call this execute before advice is actually not point cuts. Okay, we have to make sure that it's the same method that we call here execute before advices. So let's just copy and paste the name of the method, this one, and this should have as parameter, as you might see here, the target and the arguments of the method. So let's just define an object that should be the target, and an object array, that variable array, that should be arguments. Actually it's not a variable array, it's just an array returned by the special syntax $args of Java Assist. So what we do in this case, because of the way we attach this to the call, we have no information about which method is called from which class. But in order to get this, we will just get a stack trace. So let's just the elements of the stack trace. So with the current thread, not throwable but thread. So with the current thread, we get the stack trace, and that's going to return an array of stack trace elements. So when we call the get stack trace, index of 0 of top on the top of the stack trace will have the get stack trace method call. By the index 1 we'll have this method which is calling get stack trace, and by index 2 we'll find the method which is calling execute before advices. In this case is the one that was modified and where we injected the call. So what we need to get would be the name of the method, and we take it from the stack trace by the index 2, and this is the method name. Then we need the name of the class, and also with the stack trace index of 2 we get the class name. So now we know the context, who's executing. We need then to compute the key again and see what aspects we have collected when trying to apply this to a method of a type. And in the same way we were computing this, we will do here. You know what, we can have a method for that called getKey, just to make sure that we are doing it in the same way. So let's just create here a private string method called getMethodKey, and this should have as parameter the name of the type and the name of the method, and in the end we should return this, and here we should call getMethodKey, and eventually we should have the same method here, getMethodKey. In this way we are sure that we compute the key in the same way. Okay, and now what we have to do would be to take each point cut from the method point cuts get by the key, and we execute the point cut. We have to do a try and catch, and we should catch throwable because the execution might throw trouble. If a point cut goes wrong, then we don't care about the exception. In this case we are not even logging the exception, but normally we should do. So we execute the before advice with all the elements that we collected before. Now let's just do a copy paste and define the second method execute after advices, but in this case we will also receive the result of execution, the method execution. So in this case we execute the after advice, which also needs the result in here. We have to make sure, because this is accepting a variable number of arguments, so we have to make sure that after advice was defined in this way. So name of the type, name of the method, target, result, and arguments. Name of the type, method, target, result, arguments. That's fine. Okay, now that we are ready with our infrastructure, let's see how this runs. In order to run this, we need to do several stuff. First, we need to export the support for the agent as a jar. So we go to the export, we then go to the Java category and export the jar file, and for that we will just put it on the desktop and let's call it AOP.jar. Okay, now we exported this, that's fine. But then we need to edit a bit the jar because we need to define an agent inside the jar. So we open the Hive. Let me just adjust this in order to fit the screen a bit. So we go to the meta-inf and edit the manifest. We need to define an additional parameter which will be the pre-main class, and this is our aspect agent. So the pre-main class specifies what to execute before actually running the program, and we said that we should execute that. But then we need to go to the debug configuration, and in this case we should define to run our application, and this should be our AOP demo. This should run our program which contains the main, but we need to specify some additional arguments. Like for instance, we need to say the Java agent should be our class. because this class is on my desktop, I will just copy its path, so should be on my desktop, and it's called AOP.char. We then need to define an additional system property which is called AOP, and this points to the properties files. So AOP.properties is the one which is defining what aspects with what point cards to load. And because this is it's directly in the binary folder, then we need to change from which we start, which would be the current directory. And now when we debug this, we see that the aspect was not actually executed. Let's go and see what went wrong, because normally we should see that the aspect was applied. So first of all, let's just copy this in our lib folder, okay, and edit this again. Okay, not a good idea of editing in here, but I suspect that the file was not accessible by that path. So let's then just try and see what was the path of the file, okay, and use this as a value in our configuration. So this should be used as a value instead of that. The path, it's this one, okay, this is the file. And now let's just try and debug and see if it's invoked or not. So debug this again, and as you can see, this invokes, and then we should go to our class transformer and see if it's loading stuff. So what I expect to have would be to try to apply this, and when it tries to apply, it will then, before that, it will instantiate the aspect manager. So I have to make sure that it goes in here. So now we are loading the aspects. We then get the path to the AOP file. We read all the lines, which is okay in our case. We have one element. We are adding the point card, which is fine, okay. And then when we try to apply this to a method, then it says this is a method, this is the type, and we should see if this applies or not. In this case, it doesn't. But eventually, what I'm interested in would be to check if the name of the type contains service, because we are calling a type that we supposed to intercept. So what I should do in this case, I should remove some breakpoints we don't need, because we saw that the aspect was loaded, but rather go here and see if we in the implementation of my point card and see if this was called. We have a breakpoint here that was not actually called because the aspect was not applied, but we have one here as well. So let's just put a conditional breakpoint here, in which we try to see, perhaps perhaps we have the problem. Let me just check it in here to make sure. Yeah, the name of the service is AOP.service. So normally we should return AOP.service, should be okay. But let's just use a conditional breakpoint, and the condition should be that the type contains the word service. Come on, once again. So this is contains, not okay. So this contains the word service, and then let's just let it run, and it does. So we have a method here. The name of the method is say hello, and the apply, which will return true in this case. And after returning true, which was the expected result, then we put this, and of course we will have we'll know that we have to intercept this, and after knowing that we have to intercept this, we then add a call to aspect manager class get name, but there is a problem in here, and now that we did the debug we discovered the issue. When we applied the call, we forgot that the aspect manager is used in a singleton manner, so we have to call the get instance here first, and with this instance execute stuff. So then when we invoke this, we'll see that, come on, should see that. So it's the aspect manager class, get name, get instance, execute before advices. This is the correct name. Let's go and see if we actually executed the before advices once again. So let's go in the aspect manager, execute before advices, put a breakpoint here, one as well in here, and debug this again. So this actually never happened. So let's try and see that again. In the aspect, in the class transformer, we attach that. So make sure that we attach that. Okay, once again, I saw that we did. So we inserted this. Let's just see what the code translates in here, because normally this should be okay. So the call is to something that's like AOP aspect manager get instant execute before advices, and the arguments are okay. Okay, let me just see what is the issue with this, because normally this is okay, this is all that we need to do. So this is the insert before, and this is the insert after, and this should be the same, at least for the aspect part. You don't see it, it's there. Okay, so execute after advices, get instance, execute, and still didn't execute. Once again, and the reason for which it didn't execute correctly was it's very stupid actually. I managed to find that when we transform the class, we change the method, which is fine, everything worked well up to that, but we didn't change the bytecode. So come on, this is stupid. I mean, in the end, we are returning the same bytecode that we received. So what we just have to do is to convert to bytecode the type. Okay, so this is the only thing that we forgot. So we are changing the definition of the type by injecting interceptors in the method, but we didn't change the bytecode. We were returning the original argument that was here. Okay, so now when we debug this again, we see that we are executing the before, we are executing the after. I'll just go on. So you see that now my point cut interceptor, it's actually called, and now I see the type is the service, the method is the say hello, it's an instance of service on which we execute, and we have an argument which is this one. Okay, so this was invoked, and eventually we call the after, which was called on this type, the say hello method with this target. Now we have the result, which is hello, and we have the argument, which was this one. Okay, so in the end we managed to see successfully that the before advice, after and after advice were executed. Okay, so once again, what you need to do in order to implement a simple AOP framework would be first find a Java bytecode manipulation library, one that's easy to use, and of course one that's able to do what you need. This will be actually what you will depend on in order to load bytecode and manipulate it. Then you write your own aspect, which is a class containing a static method called pre-main with a special signature, which will allow you to define the infrastructure needed to intercept class loading. we add a class transformer, so you need to create your own class transformer. A class transformer, it's implementing an interface with a transform method, and then you use your library to actually load your bytecode and modify it accordingly. So as you can see, we have an aspect manager which is loading all the information about aspects that need to be attached, and it will scan the point cards inside each aspect, check if the point card applied to the method, and then insert some injections, like inserting a before or an after call. In our case, we are just dispatching the call to a method of the aspect manager. So the aspect manager does a simple job. It exposes a singleton and a singleton instance, and when actually creating the instance, it will then read a file with all the configurations, with all the aspects containing point cards that we need to attach. In my case, I have a simple model like an aspect with a point card. It's only one stuff in my case, but could be more complex. So we took the method point cards as a cache that we need to fill eventually after when we try to apply to the methods that are executed, and then we just load the bytecode. We just load the class by the name, but without using the class load. Rather, we use the Java manipulation library, the Java bytecode manipulation library. We create an instance of that type. So later on, when we try to apply the point cards as filtering the point cards on methods, then we should check with this instance whether it applies or not, and then we collect all the point cards that apply to that method. Eventually, when we execute the aspects, by the way I did it, I don't know what's the name of the method in which class we execute, but I take the stack trace for that, and then I take all the point cards for that method and execute them accordingly. Okay, so this is what I do. Something we need also to check if, for instance, if we have in the method point cards a key for that, and only when we have a key to execute the point cards, because normally in my case I called only one method for which I register the point card, but normally we shouldn't have point cards for all the methods. Okay, so this check is useful in case we are implementing a point card which applies on a type but has no aspects attached. Okay, so this could be anyway, this is just a check. The idea is that the default implementation of those advices does nothing. So anyway, it will eventually execute something, but with no outcome. Okay, so after defining this, in order to attach your agent and weave at runtime, you should export a jar, and the jar should contain, let me open this again, its manifest should have a property which is called pre-main class that's pointing to your agent, and the agent will then be executed before calling the main class of your application, and it will be able to get the information, like for instance in our case we are getting the information from a system property. So we have a system property that's pointing to our file, and then we load the file, create the point cards, and use them later on. So as you can see here, we were able to intercept whatever we needed. So thanks for watching.